there are two main components in the AirTOP software. One is the airspace modeling, and the other one is the airport modeling. The terminal module is included in this airport modeling. And today we're going to talk about the terminal. But in general, AirTOP is a unique terminal-to-terminal simulation suite that allows you scenario editing, simulation execution, debugging, reporting, make analysis of the simulations, and you can interact in 2D and 3D. It's modular and agent-based, and it helps to reduce costs and delays. Also, it's important to know that it can be connected to offline data, but also to live data, like radar, for example. So let's go into the terminal itself. So as we mentioned in the previous slide, the terminal, or the AirTOP terminal and AirTOP as a tool, it's a multi-agent-based technology that can synchronize with external applications, and it has GIS functionalities. AirTOP terminal is designed so that the users can assess the key performance indicators, KPIs, for example, the waiting time in the queues, the queue length, the density, the walking distances, the dynamic capacity, etc. Okay, in general, the IATA level of service can be calculated. Then it is used to validate conceptual planning designs. So when you are in the stages of choosing which design is the best, and you can use AirTOP in order to validate those designs. You can use AirTOP terminal as well to calculate the airport's capacity, both dynamic and static. Yeah. You obviously can use it to simulate and visualize the processes and systems and see how the reality will look like before it's actually implemented. And then you can analyze the effectiveness of new layouts. Yeah. And then the last but not least is that you can report and defensively communicate. So when you can see where the problems are, so when you make a design, you can detect in advance what it needs to be done so that everything works as planned. Yeah, here you have some examples. So in the top right, we have a picture of one airport, so you can see the check-in, security, the boarding areas, etc. And then in the bottom right, we have the square meters per passenger. This is the density or the space and level of service, right? So you can see that we have a yellow line and a red line. So basically, the space between these two lines, in this case, is the IATA level of service optimum, right? So if you are above the red line, you are giving too much, or your level of service is too good. If you're below the yellow line, then you are providing not a good level of service. Okay, so you can see over time how the level of service in this area is varying. So this is just one of the examples. Okay, so now what I'll try to do is to show you the processes of the airport as if you were a passenger, right? So typically the passengers, after the entrance, they will go to security. There might be something before entrance in some airports, but typically after that they go to the check-in or to the check-in hall. So in this example, what we're showing is a check-in hall, which includes course kiosks, automatic backdrops, and desks, check-in desks. Okay. Then you can see that there are passengers with checked baggage and there are passengers without checked baggage. So in AirTOP, you can model and simulate any passenger behavior, meaning you can simulate passengers that have a check-in online and doesn't have a bag and they go straight to security. You can model passengers that have an oversized bag and after the check-in counter they have to go somewhere else to drop the bag. You can model overweight bags as well so that they can maybe spend more time in the check-in or they have to go somewhere else to pay, then come back to the check-in again after they have paid the overweight, etc. So obviously business and economy can also be modeled, right? So all the behaviors that are currently in place in the industry can be modeled, okay? And also new ideas of new behaviors can also be modeled. So just to give you some introduction about that. Now, one of the great features that we introduce in AirTOP so that we make this AirTOP terminal a more operational focus, not only planning, is the check-in allocation. So we introduce a feature that allows the user to calculate the check-in counters that are needed given certain parameters. And based on that calculation, it allows the users to allocate the counters, right? I'll show at the end of this presentation, I'll make a short demo to show how this feature works. But basically, here on the left, we have the GUI in which this is shown. You have different parameters. So you can do it by airline or by flights. You can select which flights you want to calculate the estimation for. You can cap the minimum and the maximum number of counters that you will allocate. You can determine when or which is the minimum time that a counter needs to be allocated, meaning that once it's allocated, you have to be, in this case, at least 30 minutes allocated to that airline. You can define that, okay? And then the rest are just parameters for the calculation. So the higher the randomizations and the reducing steps are, the more refined the solution will be. And then we have the target, right? So for different passenger conditions or for different type of passengers and airlines, we can define a target. So in this case, just as an example, we say if the Star Alliance, the target is not to exceed 20 minutes. For SkyTeam, not to exceed 15 minutes. For One World, 10 minutes, etc. Okay? And after we set up all these parameters, then we just run this feature and immediately we'll get the results, right? And the results will look like the ones that are in the right side of this slide. So for example, you can see that for One World, at different times of the day, you need a different number of counters. So you need 3, then 5, 7, 10, 6, and 6, right? If we go to another one, for example, this one, there's another airline actually, Delta, so it needs 3, 7, 8, 9. Okay, if we go to this airline, then okay, so it allows the user to calculate at any given time how many counters are needed, so that it can use this as a planning for the future, but it can also use this operationally because it will allow to understand when and how the allocation should be done. Okay, Once the calculation of the check-in counters is done, then the next step is, if you want to put it in place, of course you can finish there if that's the only thing you needed, but you can also put it in place and see if with that requirements you can fit it in your airport. So we have the second step of this tool is optional, but if you decide to carry on, then it allows you to allocate the counters, right? So again, there are certain parameters that you can choose, right? And you can decide where they need to be allocated. So for instance, in this case, what we have is that a Star Alliance needs to be allocated from counter 1 to 15, One World from 16 to 30, etc. Right? Then after you set up these parameters, you run the second step, and it will generate the check-in allocation. Okay, if there are flights that could not be allocated because there were not enough check-in counters, then it will pop up an error message telling you which flights could not be allocated, right? And then the user can decide if it continues with that, if it adds more check-in counters, if it wants to reduce counters allocated to other airlines, etc. Yeah. Then, of course, after you have allocated and you have seen that you have enough counters to meet your requirements, then you want to analyze the level of service, right? So you can run the simulation and then pull out the reports. So here we're just showing you two kind of reports that you can do. One is the queue length. What would be the maximum number of passengers waiting in the check-in, and also the queue time. What would be the maximum queuing time in the check-in, for example? Yeah. Okay. So after passengers have checked the baggage, get the boarding pass, and so on, then the next step for them is to go to security, right? So before, in the previous slide, we just showed you a 3D model. In this case, we are showing you a 2D model just to illustrate that you can use both the 2D and the 3D visualization to show how the airport or how the terminal is working, right? In this case, what we have is a fairly detailed model of the security, with these yellow lines being the backdrop positions, the green square being the magnetometer or the body scanner, then the red lines being the body checkers, and the orange lines being the pickup area. Okay, and you can go as deep as you want to get more details into the security process and all the processes, or you can also go more as a high-level simulation, right? So you might not need to go into that detail. So you might want to just make just a process here, what we call a black box, right? So that the passengers will get in and out after a certain time, right? So AirTOP allows the user to go from micro modeling, which is a high-level black box concept, to the micro modeling, which allows you to go into the details of each of the processes at the terminal facility. Okay. Now, when it comes to security, but also security, immigration, customs, etc. What we are interested in planning, it's obviously to know what would be the behavior or the performance during the highest peak. But operationally, what we're interested is in knowing when or how many resources do I have to open at different times of the day, right? So we also created another feature that allows the user to calculate the number of resources that are needed at any given time, and that any given time is actually defined by the user. So you can define it as you every hour, or every 30 minutes, every 2 hours, etc. Okay. So in this case, for example, it's showing the number of security lanes that need to be open, so that we are within a range of waiting times, right? So we don't exceed 15 minutes waiting time, right? So we can see that as soon as the waiting time is getting up, then more security lanes have to be open, right? So we start with 5, then as the congestion keeps increasing, or the waiting time keeps increasing, then we need to open 2 more, then another 2, then they're kept, then at some point it goes down. Okay, so there is a variation on how many security lanes need to be open, right? And this shows you like the story on how your resources should be allocated, but you also have the raw data, right? On the right side, you can see this raw data. So you can see that, for example, the 6th security lane should be open for 1 hour, right? And the 6, 7, 8, 9, they have to be open quite close to each other, right? To keep this level of service, right? So then you can see exactly when you need to open and when you need to close the extra security lane. So it allows you to calculate the resources, make some kind of roster for the employees, etc. Okay. Then after we have passed security, so in some airports we will go to passport control. Some airports have passport control before security, but typically we can say that we can go to the secure area, in which we have the retail, we have the beverage, food and beverage, the business lounges, and the boarding areas, right? So AirTOP allows to model all that kind of behavior. You can direct the passengers to go to retail, to go to beverage, then go to business lounges, then go to boarding. You can decide when they have to be there, how long they have to be there, or when they have to leave that each area in relation to the departure time, etc. Right? And then once the passengers get to the final stage, which is the departure lounge, then you can decide how to board the passengers. You can decide which is going to be your boarding strategy, right? So AirTOP allows you to test different boarding strategies, so that you can analyze if one gives advantages against the other. You can also analyze if different stand allocation gives you different results, etc. Here, what you can see is an example. So in this case, what we see is that there are 5 boarding groups, 1, 2, 3, 4, 5. Each of those groups will board or will be called to board at different times, right? 30 minutes, 20 to 25, 15 to 20, etc. And based on this boarding behavior, then we get some results. So this blue graph, what is showing is the number of passengers that are waiting in that area. This allows you two things. One, it allows you to know if you have enough seats, if you want to meet the certain level of service, for example, 70% that IATA states, right? And it also allows to calculate if it's big enough so that even if passengers are not seated, they still can be standing, but with enough space, right? And it allows you to see actually the variations after a flight has been boarded, right, and so on. Then on the right side, we have actually the boarding, like the passengers that have been already boarded, have crossed the boarding counter or the gate. Okay, so then you can see in this case there are four flights, right? So each of these is it's a 5 minutes interval, so you can see that different flights have, depending on how big or how many passengers they have, they can take longer to board or shorter, right? So then you have the full analysis. Okay, so with this we would finish the departures, and we now can start with the arrivals. So in the arrivals, or an arrival passenger, after it deplanes, it goes to the arrival hall. Then if it's domestic, it just goes straight to reclaim typically. If it's international, then it goes to the passport control, right? So here what we're showing is an example on how passengers deplane, then walk onto the corridors, then to reach the passport control. In this case, you can see that there are e-gates, okay, automatic passport control, and we have also a common immigration desks, right? So, for example, you can see you can analyze how many e-gates and how many desks you will need. You can analyze, for example, typical behavior is that some passengers are refused or rejected by the e-gate, and they have to go to the desk. So then you can analyze how many desks do you need to put or to devote to that matter, etc. So all that kind of behaviors can be accounted here. Okay, so just to illustrate, in this case, what we're showing in these graphs are the waiting time incurred on the e-gates on the left, and then on the right, the waiting time incurred on the checking and the immigration desks, right? Then again, here we have also the level of service lines, yellow and red, and everything that it's in between, it's the IATA level of service optimum. So anything that it's below, it will be over providing, and everything that it's above will be under providing, right? So then you can immediately see in the graph if you're meeting your level of service or your requirements. Later, I'll show you a little bit more about this. Yeah. And then finally, in the process of the arriving, what we have is the reclaim. So the passengers will get down to the reclaim, pick up their bags that will be delivered, and then leave. And perhaps they can meet the visitors outside, or they just go straight to outside the airport. But there are a couple of things to mention here. One is that there is a connection between the passenger and the bag, meaning that each passenger is assigned a number of bags, right? Then when the passenger deplanes, it goes through all the arriving processes, and when it arrives to the carousel, if the bag is not there, then the passenger will wait for the bag. Okay? Then the bags have similar journey, let's say, but in this case, if you only simulate in the terminal, then they will appear at the carousel based on a distribution. Then if they appear at the carousel before the passenger arrives, they will keep looping until the passenger arrives. If once the passenger arrives, then the passenger will pick up the bag. Okay? So it allows to simulate the real behavior of what's happening, right? So you can see the impact of delays on the delivery time, for example. So there will be, if there's delays in delivery time, then there would be a lot of congestion around the reclaim. But you can also see the effect of, for example, an immigration congestion, right? Like if there is a lot of congestion at the immigration, the bags might arrive first or before the passengers, right? So then the carousel will get full before the passengers can actually pick up the bags, right? So all that can be accounted. And also we have the possibility to assign the reclaims to the flights based on many conditions of the flight, right? Based on how big it is, the aircraft, the size of the aircraft, where it is located, if it's domestic, international, etc. And just to illustrate a bit how, like, the impact or the analysis that you can do. So on the upper side, on the upper side of this slide, what we have is an output when passengers have 1, 2, or 3 bags, and on the bottom side we have when all passengers have 1 bag, right? So you can clearly see the difference. That first, the number of passengers waiting to pick up the bags is reduced, right? And at the top we have 350, while we have 300 at the bottom. But also the time the passengers are waiting, it's also reduced, right? At the top, we can see, for example, this, like the last pyramid, we have from 10 to 11:30, right? While if we go at the bottom, we have from 10 to 11:10, right? So it takes 20 minutes less to clear the reclaim, right? I mean, that's expected, but it's just to see the effect and the impact that it has, right? So the simulation helps you understand that. Okay. Now, the next step, or the next topic, is the connection with the Airside, right? So typically the connection with the Airside will be through the stand assignment, the terminal delays, and the baggage claim. So Airside and terminal modules are connected through the stand assignment, right? So the parking positions are the, let's say, for a departure flight is the last step on the terminal and the first on the Airside. And in an arrival flight is the first step on the Airside, the last step on the Airside, and the first step on the terminal, right? So the stand assignment allows the connection and between the two modules. Then planned stand assignment features are available in both modules, Airside aircraft and terminal. If someone is looking for dynamic stand assignment, this means that reassign a stand to a flight or assign another stand to a flight if the planned stand is occupied, that is only available on the Airside aircraft module, right? So you will need to have both if you want to have dynamic stand assignment. Then if we go to terminal delays, we have the possibility to delay aircrafts, and that means incurring stand delays, right? So, for example, a boarding can be delayed if the aircraft is still being deplaned, right? So imagine a turnaround flight, a short turnaround flight of 25 minutes. Then the plan is to deplane it within the first 10 minutes and then start the enplaning just right away after 15 minutes. But it could take longer to deplane. It could take 15 minutes, right? So then the boarding that was planned 15 minutes before the departure time will have to be delayed for 5 minutes in this case, right? Then if the boarding is delayed, then obviously there is a potential pushback delay, right? Because if the boarding is delayed, then the time it will take for the passengers to board will be longer, so there could be a pushback delay, right? Delaying the aircraft to depart. And then if there is a pushback delay, obviously it could be a choke zone delay, right? So an aircraft that is planned to park, an arrival flight that is planned to park on that stand, but still, since there is a pushback delay, then it cannot park and it has to wait, right? So all these can be accounted in the terminal and it's connected to the airside. Then in the airside aircraft, there is also the possibility to reassign stands, right? So in the choke zone delay, you can decide if you want to reassign the stand or if you want the flight to wait. In the terminal, the only option is the flight waits until the stand is available. And then next is the baggage claim. So the baggage claim is related to the flight, to the aircraft, and where the flight is parked, right? So you can make the delivery time, for example, based on where the aircraft is parked. You can make the delivery time based on this ground service equipment company that is serving that aircraft. You can make it based on the airline and many others, right? So everything that is related to the airfield that affects the baggage claim can be inputted in the terminal.